Production possibilities frontier. So that's similar to the idea of consumers or individuals' budget constraint. Just as individuals cannot have everything they want and must instead make choices, society or country as a whole cannot have everything it might want either, right? The PPF or production possibilities frontier will model this society's trade-offs between the production of two goods. So possi uh, production possibility is restricted by our technologies and our resources, right? So suppose our country has 1 million workers. That's our resources, all the resource we have, right? And it takes 100 workers to make one car and 10 workers to make one trunkload of food. That's our technology. So our ability to turn resources into desirable goods is called our technology, right? So combine our resources and technology, we can calculate our possibility frontier, right? So what's the maximum value of food we can have, which should be obtained when we allocate everyone to make food, right? So if everyone is making food, we will get 100,000 food. So the maximum value of cars we can have similarly is obtained when we allocate everyone into car production. In that case, we'll have 10,000 cars, right? So put these 2 points in the intercept. So if we have 0 cars, at most we can have 100,000 food. And if we don't have any food, at most we can have 10,000 cars, right? And connect these 2 lines to 2 points together, we can have our PPF, right? This PPF, this line, will divide our whole region, whole area into 3 parts: the green triangle region, and the line itself, and the outer part, right? So for any points in the green area, it's possible combinations to produce, but inefficient. What does it mean by inefficient? It means starting from point A, we can increase food and increase car at the same time. We don't have to give up anything if we want to produce one more, right? So because in that case, we are not using all the resources we have. So that's inefficient. At point B, it's efficient because if we want to increase one good, if we want to increase car production, we have to give up. We have to reduce some food production, right? So because we are using all the resources to produce, that's we got the efficiency. So productive efficiency means given the available inputs and technology, it's impossible to produce more of one good without decreasing the quantity that is produced of another good. So any point A, it's possible but inefficient. Any point B, it's possible and efficient because we're using all the resources. We cannot increase both production at the same time. For point C or above the PPF, it's not possible to produce, right? Because we can never find any reasonable allocation of our resources to get that output, that amount of output. So similarly to the budget constraint, with the PPF, we can also calculate the opportunity cost because if we want to produce more cars, we have to give up some food, right? That's the idea of opportunity cost. So what's the opportunity cost of one food? That's the number of cars we could make using the resources from one food, right? How to calculate that? That's equals to the number of cars over the number of food because 10,000 cars is equalized to 100,000 food in the resource terms because they are using the same amount of resources, which is 1 million workers. Right? So that will become 0.1 cars is equalized with one food in resource terms, which means the opportunity cost of one food is 0.1 unit of car because they are using the same amount of resource. So if we want to produce one more unit of food, you have to reallocate resource from car production to food production. If you do that, car production will be reduced by 0.1 unit. That's the opportunity cost, right? Similarly, we can calculate the opportunity cost of one car, which is the number of food we could have made using the resources from one car. So again, that's the food over car because they are using the same amount of resources. That becomes 10 food is equalized into one cars in resource terms because they are using the same amount of resource. So the opportunity cost of one car is 10 food. So if we want to produce one car more, you have to reallocate people from food production to car production. So that will reduce the food production by 10 units. So before we have the PPF as straight line, but in other cases we'll have curved PPF. What's that case? It happens when we have heterogeneous resources, which means if we have some people, they are better at making food, while others, they are better at making cars, we'll have this curved PPF. Why is that? So suppose again, we start from point T, the intercept here, which means we are having everybody making food. So at most we can get 60,000, right? So now if we want to make more cars, we need to allocate people from food production to car production, right? What's the efficient way to do that? We should initially allocate people who are better at the cars from food production to car production, right? So from this point to K, we are moving people who are good at cars but bad at food to produce cars, right? So we are only giving up a small amount of food because it's people who are not good at food. And we can get a large amount of cars because they are really good at cars. So that's why initially we'll have a relatively flat uh, slope, right? But from K, if we want to going beyond, if we want to more cars, now all the people who are good at cars is already producing cars. So if we still want more, we have to move people who are good at food but bad at cars, go to produce cars. So in that way, we will have to give up a very large amount of food to produce just a small amount of cars. So in the end, the slope is going to be steeper. That's why we will, in that case, we will have a curved PPF and curve outwards. So there are some cases that our PPF can change. Remember, our PPF is defined by our resources and technology. So either resource change or technology change will cause our PPF change. Right? So here, consider a case where we improve the technology of making cars, but our technology of making food is not effective. In that case, we should have the same intercept as the food because our food technology is the same. It happens when we make everyone producing food, right? We should have the same amount of food because our food technology is the same. But if we are making any cars, we should have more cars because we are better at making cars now. So the PPF is moving to the right, but keep the intercept the same. Another case is change in resources. So suppose our country experienced a significant influx of immigrants, right? Now we have more people. In that case, our PPF will expand also to the right and to the upwards and the two intercept will move because in each case, either we are only producing food or only producing cars, we can make more because we have more people, right? So that's the change in PPF.